Hey everybody, Carl here, and today we're going to do a video that's a little bit different. It's still along the lines of our series that we're doing right now, but I want to back up just a bit back to the amplifier part again. Uh, so this would be like, here's our main deal that we've been following, our main series, and this is going to be like a little sub part of it. And what I want to cover today is the use of op amps. Now, if you remember when we were doing the amp part, we found that the LM386, which is it's an audio amp, and it's designed for that, and it's one of the best choices you can have if you're going to do this. And it's got power, and like I said, in it you can be very simple with it, or you can get crazy complex. But to drive it, because we are picking up on such a small signal, we tried two different things. We tried the NPN transistor, which worked pretty good, and that was a lot of fun. But then we also tried the LM741 op amp, and we used that as our preamp. And I'll tell you what, and although I was screwing around with it and I really didn't set it up the way I should, we can make it work even better. And that's what I want to do today. Not only do I want to show you how to basically set one up real easy, but I want to show you how they work. I mean, there's a lot of schematics, there's a lot of circuits out there that utilize op amps, and they're great for what they do. I mean, they're like a fantastic little tool. So, but they're one of those things that they work, but how do they work, and do I even really want to know why? But I'll tell you what. The basics of them, though, at first it doesn't make sense and doesn't sound right. Once you kind of get it and understand it, you go, oh, that's simple. It turns everything simple. And then anytime you look at an op amp from now on, you'll know exactly what it's doing. So I thought we'd kind of cover that. And by the way, I just wanted to mention that if you really want to get a good lesson, because I'm not a professor. But I'll tell you what, Dave Jones on the EE blog, he's got a fantastic tutorial on it on his tutorial Fridays. Just look up op amp basics, and he's got a really good one on there. It's from the it's in the past, but just dig it up. That's a good one. And also earlier this month when he had his guest hosts on, he had this other guy kind of explaining how the op amps actually work to balance, and we're going to kind of go over that just a little bit too. But I thought it would be fun to not only show you how to set up a LM741, but how is it working, and why do we choose it? Like I said, we're taking a very, very small signal, hardly any power or anything, and we want to, in the end, try to push it maybe even through a speaker, headphones at the least, and a nice speaker at the best. But to do that, because it is so weak, we need something that maybe on the one end is a high impedance, where there's very little there, just in you can grab that, and the output then is a low impedance, and that's exactly what op amps do. And I'm going to try to explain why with all this, but first I thought I would just show you. I've got one set up here on the breadboard, and I want to kind of just give you an example of what it's doing. And it's just the 741. I don't have the 386 hooked up or anything else. I'm just going to run it out of my little AM transistor radio through the 741 op amp into a little tiny small speaker, and I'll just show you, how it works, and just the basics, and then we'll actually go on the like little whiteboard or whatever I can come up with to show you actually what's going on in the circuit. Okay, so hold steady here. All right, everybody, you can hear the radio's on. Right in the center here is the LM741. I've got it hooked up real basic. I can show you. There's just a couple resistors, a capacitor out, and that's the basics of it. Now I'm running that through my little AM transistor radio. You can see on the oscilloscope. Now this is the input. All right, this is on the input part of it, and I'm running out into this little speaker here, and I've got it set up with. I'm actually running the op amp on 18 volts positive and negative, and then I've got a virtual ground where I've split the difference like the voltage divider at 9 volts. So all the grounds are going to the 9 volt part, but the op amp itself is running at 18. Now I'm going to take and I'm going to hook the scope up. Right now it's at the input there. I'm going to hook it up to the output. Give me 1 second. Okay, now you notice right here I've got the scope probe hooked up to the output, and look at the difference. I mean, quite a bit. And I tell you right now, I have the radio turned way down, so it's not putting that much out. Now imagine running this into the LM386, and we should have a pretty good signal coming out. So, okay, so that's that. Now let's take a look and see how this is actually working. Why do I have the resistors where I have those? We know why the capacitor's there. That's just to filter out. But what are those resistors doing and what's going on? That's what we're going to look at next. Okay, here I've got the basics laid out for us. Now we're going to, if you notice that little formula right there, we're going to go over that later. And right now we got to remember that we're going to look at a non-inverting setup. Okay, our LM741, we're going to set it up in a non-inverting amplification setup. So let me see if I can get this set up a little bit closer here so we can take a look at this. Okay. Now on the 741, now there's 8 pins, and we know that. And matter of fact, let me look at that first. And this is all op amps, most all op amps. Okay, when you look at an op amp, there's usually like a little notch at the one end, and there'll be a dot. And where that dot is, that's pin 1. And the way and on the 8 leg, and it goes for all of them, if it was like 14 leg or whatever, on number 1, it will start up here and it'll go 1, 2, 3, 4, and then it'll jump across, and then the bottom one will be 5, and then up 6, 7, and 8. Now that's, like I said, most all op amps would be that way. And if it was like a 14 pin, it would go down to like 7, jump across, come up to 14. But here so these are the way the pins are laid out on this. And it's also laid out like this on the 386 when you're working with that. So now while we know that, then let's take a look at this. See if I can get this steady so it'll hold here. All right. Now the way this thing is set up, pin 1, don't worry about pin 1. Pin 2 is your inverting or like minus input. Okay, that's your inverting input there. Number 3 is your non-inverting input. So these are the two inputs you're going to use. And you use them both. We're going to use them both when we set this up. Pin number 4 is our negative voltage. So like I said, I'm using 18 volts. Down here would be the minus 18. This is it'd be the negative rail, but we're going to use it as a negative rail. In other words, negative 18 up here. Number 7 is the positive rail, so we've got plus 18 up here. We'll have negative 18 down here. Now, like I said, I mentioned the 9 volts, and we'll get around to that in just a little bit. And then 6 is the output. Okay, so don't worry right now. We're not going to worry about pin 1, and we're not going to worry about pin 5, and we're not going to worry about pin 8. These are the pins that we're going to use right here. Okay, so what do we do with these? What happens? Well, okay, a couple things that you have to remember about an op amp. There's two things it basically does. And if you can remember that, you'll be set really good on knowing what's going on. First of all, there's a whole circuit in here, and don't forget that this is not like a transistor where you have, you have a signal coming in and it goes out and it does something, it gets amplified. It's not the way this works. The first rule is there is no voltage or current, I should say, coming in or out of either of these inputs. There isn't any current going in, and there's no current coming out on either one of them. And it makes you think, well, then how does it work? I mean, if you don't have voltage coming through it, I mean, how's it going on? Well, we're going to get to that, but just remember that the circuit inside is doing the work for us, okay? So, rule number 1, no current comes in or out. Now, the second rule that op amps follow is this circuit inside always tries to keep a balance between 2 and 3. And that's like a balance of voltage. So, like, let's say if you have 4 volts on pin number 3, and you have you'd have 2 volts on pin number 2, it's going to do everything inside of here it can to create this pin to have a balance of 4, or this to have a balance of 2. Now, I know that's starting to sound weird, and you're thinking, oh, geez, where's this going from? But, okay, just think. If you have 2 volts, let's say, coming into pin 3, all right, this op amp is going to do everything it can to make sure that there's 2 volts on this here, too. And that's where the circuit comes in, because the circuit is doing it. It's reading it. It doesn't necessarily, it's not bringing it in and doing this and that and pushing things out. Remember, there's no current that comes in or out of these. So how does it do it? Well, the way we're going to do it today, and this is going to be, like I said, this is a non-inverting amplifier. So we're going to take a signal that comes in the non-inverting side, and somehow we're going to get it amplified to where it comes out. And how are we going to do that? Well, there's a thing that we're going to use. It's called feedback. All right? And let me get this set up, and we're going to talk about feedback. Okay, feedback. Now let's say that let's just say we have 1 volt coming into pin 3. It's coming into the non-inverted pin. Now, this op amp is going to want to make this pin 1 volt also. So what does it do? Well, and remember, we've got power coming in. We've got positive and negative power. So there's power running inside of here. As of right now, there's like 18 volts we can play with, right? Okay, so the op amp sees this 1 volt coming in. It says, okay, well, 2 has to have 1 volt also. So because we've got a feedback loop, it puts out 1 volt here. It loops around, and it puts 1 volt on 2. And now it's balanced. So the gain would actually be 1. We'd have a gain of 1 on this. It'd be a it's just, and what they call they use this to buffer. Okay, they use it as a buffering amp. And we can get into that later, but I mean, just think of this. Let's say you didn't want to amplify that right now. You wanted to keep that signal real small, but have a little bit of oomph behind it. Keep the voltage the same. So you have like high impedance here. You got the voltage in here, and so you've got the oomph from the power in here. So you can put out a stronger 1 volt here because of the feedback loop. All right? So what it's doing, it's not amplifying it. It's just kind of giving it more oomph, you know what I mean? Some of you by now understand Carl speak, so you know what I'm talking about. But, okay, so that kind of gives you an idea of what's happening inside of here. It's seeing 1 volt here. What does it have to do to balance? Because the op amp wants both of these pins to have the exact voltage. Well, it has a feedback loop to it, so it puts out 1 volt here and sends that 1 volt back to 2, and so now it's balanced. So you got 1 to 1. But let's say we want to bump that up. How do we do that? Okay, let me set up for that, and we'll take it a step further. Okay, so now we have our op amp, and now what we want to do is we want to put 1 volt in, but we'd like to get 10 volts out, or we'd like to have a gain of 10. So what do? Well, we still have the 1 volt coming in here, but now we need to have 10 come out of this end. And how are we going to do that? Well, we're going to use a formula because of this feedback loop here. We got to make this circuit in here push out enough power here to where when it gets back to 2, it's 1 volt. And in the circuit, like I said, it'll do what it has to do to put it out. And it's got, now remember, we're working with 18 volts, and we can't go over 18 volts, right? I mean, we can't, we can't get 20 volts out of this. So we got to stay within our range. If we want to do that, we got to go down the road, bump it up, and have a higher, bigger kind of amplifiers. This one, and we can look at the specs later, but this one goes from like 18, I think, to 24. Anyway, okay, so what happens here? All right, let's take a look at our formula first. Remember we talked about that formula? And we said the gain equals 1 plus R2 over R1. Now, before everybody starts freaking out, going, oh, I don't want to do the math and stuff, and, because I'm not real crazy about it either, we're going to break this down and make it real simple. So hang with me, okay? All right, so let me put this back up here. And, okay, so R1 is going to be 1K, okay? And R2 is going to be 9K. So when we have, anytime we have one number over another number in a fraction, you take the lower number and divide the upper one. So 1 goes into 9 times, right? I mean, this is, this one, like I said, the formula, when you first look at it, you go, oh, man, But when you think about it, all you want to do is you divide R1 into R2. So if this was 2K and this was 18K, would still get 9, okay? But like we said, we wanted to have 10 volts coming out. Well, the formula, remember, the formula starts at 1 plus whatever R1 divided in R9 is. So we've got 1 goes into 9 times, plus 1 gives us 10. So we've got 1 volt coming in. We've used our feedback loop. We've got a voltage divider right here. And by using that simple formula, we've got our 10 volts going out. And that's the basics of it. That's, it almost sounds too simple. But if you just remember, when you're doing, this is always going to be the one, the R1 that's going to be on the bottom, and it's going to divide into the one on the top. And so let's say you would want 100, 100 times going out. Well, you could do that, but you got to remember that, we can only have so much power coming in and going out. All right, now, like I said, we only have 18 volts, right? But what's going to be fed into the input? Probably not a volt. Probably more like millivolts or even microvolts, right? So let's say we wanted to have a gain of 100. How do we do that? Just to make it simple, you could have the R1 still be 1K and just change that to 100K. And would end up, you still have the plus 1, but at that point, it's not that big of a deal. You still got a gain of 101 there then. So by manipulating and using these resistors, and there's a reason they want you to have a minimum of 1K. And I'm not really sure what the deal is on that, but think of that as like a starting point for these resistors down here. Use a 1K and go up from there. So let's say you had a 10K and a 100K, and you wanted 10, then 10 and 100, you'd still have your 10 or 90 or whatever. But by using these combinations, you can pretty much get what you want. And that's the cool part about this. Now, my goodness, these there's so many different uses for these. I mean, you know, we're talking about the non-inverting ampere. Like I said, if you go to Dave Jones, he talks about the inverting, and a lot of other people do too, and they will tell you all, you know, you'll get a lot more information in here. I'm trying to give a very, very basic explanation just so you can understand how these things work. I mean, the basics of them are all the same. So, you know, if you understand just this little bit here that we just went through, you pretty much got it for all of them. And, you know, down the road, you can look at a circuit that has an op amp in it, and by using those little rules that, first of all, 3 and 2, you know, the input and the non-input, they have to equal out. This op amp is going to do everything it can to make these two inputs identical. And then so, you know, you can go from there and see what's going on. I mean, you know, it's how in-depth you want to get. But I wanted to bring this to you, and I hoped it would help. And because now the next thing we're going to do is I think we're actually going to try to put all this together and then see how it works. I'm gonna try to use this 741. I'm gonna plug it into 386, and that's going to be our amplifier out. I'm going to use our little radio that we built a while back. Let's see, where is it? Let me get it here. That little radio right there. And I'm not sure which amp. I mean, we could use, transmitter. We could use that one. We could use the one with the crystal. I could use the talking house. It doesn't, you know, one of them, they all work. That's a cool thing about it. So I wanted to put this together, and I hope this helps give you a little bit more understanding of what's going on with these op amp chips. And, you know, thing is, once you get, like I say, you can do all kinds of stuff, and it's a lot of fun. Okay, everybody, you have a good one, and I'll see you on the next video. Take care.